Hello. In this video, we're going to continue our discussion on elements. Specifically, we're going to talk about metals, nonmetals, and metalloids. So on our periodic table of the elements, there are a few elements where we can draw this zigzag line. And that's sort of the dividing line between metals and nonmetals. But additionally, along that diagonal line are some elements highlighted in green that are called metalloids. So let's look at a larger periodic table. So this is the periodic table that I posted on the Canvas website. And you'll notice if we start at boron, we can draw, actually let me highlight, we can draw a diagonal line going all the way down. And that's our dividing line for metals versus nonmetals. So everything to the left of that is a metal. So metals. And then everything to the right of that diagonal line is a nonmetal. Except for a few of the elements that lie along that diagonal line. So boron, silicon, germanium, arsenic, antimony, tellurium, etc. So those are metalloids. So let's write metalloids. Those are in green. Now, another exception is hydrogen. So hydrogen is actually a non-metal. But we put it in group 1 because it does have some properties similar to the alkali metals in group 1. Now, in some periodic tables, they list hydrogen above fluorine because it is a nonmetal. However, it doesn't have a lot of the same properties as the halogens, so we tend to include it in group 1, even though it's not a metal. Okay, so feel free to print out this periodic table and write notes on it. You can use highlighters, or you can just write in pencil or pen, whatever you need to learn all of this material. Feel free to mark up your periodic table. Okay, so let's talk a little bit more about metals. Metals, except for hydrogen, remember we just said that was a non-metal. They are located on the left side of the periodic table. They are shiny and ductile, which means they can be drawn into wires. They're also referred to as malleable, which means you can hammer them into sheets. Additionally, metals can conduct heat and electricity. So off to the right, we have the example of silver. And we can see that that container of silver is shiny. It's been shaped into its current configuration. And it's also able to conduct heat and electricity. Now, metals are usually solids except for mercury. Mercury, which has the symbol Hg, is a liquid at room temperature. Now, nonmetals, remember, are located on the right side of the periodic table, and there are not that many nonmetals. I believe there's only about 20 or less nonmetals. So nonmetals are dull, brittle, and they're poor conductors, but they're often good insulators. They also have low densities and low melting points. So sulfur, shown on the right, is a nonmetal, and you can see it's kind of powdery, it's dull, and it's brittle. Now, antimony is also shown in this grouping, and antimony is a metalloid. And metalloids have properties of both metals and nonmetals. So metalloids, again located along that heavy zigzag line that we drew on the periodic table, those again exhibit properties of both metals and nonmetals. Now, along that diagonal line, we also have aluminum and an element at the very bottom called oganesson. Those are not metalloids. So aluminum is a metal. Now, metalloids are better conductors than nonmetals, but they're not as good as metals. In fact, metalloids are called semiconductors often because they can both conduct electricity, but they can also act as insulators. So they are semiconductors. So one really good example of a metalloid is silicon. And this is often found in computers or computer chips, or even solar panels. And silicon, because it's present in computers, that's how Silicon Valley got its name in California. So silicon, again, can act as both a conductor and an insulator. All right, so let's identify each of the following elements as a metal, a nonmetal, or a metalloid. So definitely reference that periodic table as you go through this problem. And if you want to pause the video and try this on your own first, feel free, and then we'll go over it together. Okay, so A is sodium. Is sodium a metal or a nonmetal or a metalloid? So let's go to our periodic table. So sodium, enjoying teacher? Not now. So sodium is, let's see, let's use a different color. Sodium's right there. It's number 11 on the periodic table. And it has the symbol Na. So that is in group 1, which is the alkali metal group. So it's in the name. It's a metal. What about chlorine? So chlorine has the symbol Cl. So that's right here. It's number 17. And that is to the right of the diagonal line. So it is a nonmetal. Silicon, we already said, was a metalloid, and it falls right on that diagonal line that we drew. What about iron? So iron has the symbol Fe, and this one's a little tough to find, but it's right in the middle of the periodic table there. It's in the transition metals. So remember there was that group of elements that we were going to kind of ignore for the most part. So those are the transition metals or transition elements. But iron is a metal. Now you could also picture iron and know that it's a metal, but we're trying to kind of associate metals with the periodic table. All right, and then carbon. So carbon is right here. It's element 6 on the periodic table. So carbon is just to the right of boron, which is a metalloid. So carbon is actually a non-metal. Now, carbon is actually what's found in your pencils. So we often refer to pencils as containing pencil lead, but that's a misnomer. Um, Pencil lead is actually carbon or graphite. And if you think about your pencil graphite, it is pretty brittle, and that's what gives it its ability to transfer to your paper. So now carbon can also form diamond, which is a really tough stone. And diamond doesn't really bring about images of dull and brittle, right? But carbon is a non-metal, so we will keep it that way. All right. Now, let's link some of the elements to our health. Now, of all of the elements, 20 of the elements are essential for the well-being and survival of the human body. So, 4 of those elements, oxygen, carbon, hydrogen, and nitrogen, and their symbols are O, C, H, and N, those make up 96% of our body mass. So if you've taken biology courses before, you might already know that carbon, hydrogen, nitrogen, and oxygen are found in what are called amino acids. And amino acids make up different proteins. And proteins are what allow us to really function. But additionally, hydrogen and oxygen are found in water. And water makes up about 55 to 60% of our body mass. So those 4 elements are really important. But additionally, there are macrominerals like calcium, phosphorus, potassium, chlorine, sulfur, sodium, and magnesium. And these are located in periods 3 and 4. And these are involved in the formation of bones and teeth. So for instance, calcium is really important for the health of our bones. They're also involved in the maintenance of heart and blood vessels, so muscle contraction, nerve impulses, and acid-base balance of body fluids. So sodium and potassium are really important for the function of our cells. But additionally, they're also important for our nerves to function. And then other items like magnesium, for instance, can help with acid-base balance of body fluids. So if you've ever taken Tums, for instance, if you have an upset stomach, that often contains something like calcium carbonate or magnesium carbonate. And the ions can help with reducing acid in your stomach. So this periodic table highlights the different elements that are essential for our health. So in red, you'll notice hydrogen, carbon, nitrogen, and oxygen. And those are the 4 major elements in our body, or our bodies. We don't all share a body. Macrominerals are highlighted in blue. And then there's also microminerals, which are highlighted in purple. So we just have trace amounts of those elements, but they are required for our health. So for example, iron is pretty important. If you don't have enough iron in your system, you can become anemic. So you can bruise really easily. You can feel really tired. Let's see. Iodine is also really important for the function of our thyroids. And there's a few others in there that are also pretty important. But anyway, it's interesting that only 20 of the elements are really important for our health. The rest of the elements, they're also important for our world to function. They have different purposes. But I know some of you might be interested in going into a health-related field, so I just kind of wanted to point out some of these. So in the next video, what we're going to do is take our knowledge of elements and apply it to what's called the atom. So the atom is the smallest particle of an element that retains the characteristics of that element. But that's for another video, so I will see you in the next video.